Okay, in this video I'm going to continue on with exercise 4B of the book Fundamental Applied Mathematics. We're on page 107 and the question is 28. Now before I continue, this type of question so far hasn't come up in any of the questions in the book, and I've always found them reasonably difficult. However, that was until I started thinking about them in the right way, and I would hope at this stage that if you were at least listening to my videos, then you would be thinking about them in the same way as I am now. So these should be just fine for you. So it reads, a man walks due south at 1 meters per second. The wind appears to come from southwest, corresponding to this part here. When he walked due north at 3 meters per second, the wind appears to come from northwest, corresponding to here. Find the velocity of the wind. Now, the thing to notice here is the man is moving direction, but the wind never moves direction. Alright, so I've just drawn arbitrarily the velocity of the wind. It doesn't necessarily need to be going that direction. I just want to show you that it doesn't change. The next thing is that the velocity of the man changes, going from a southerly direction to a northerly direction. And he perceives the wind in two different cases to be blowing in two different directions. So what we have is the velocity of the wind relative to the man. And the reason we have that is VWM means the man is in a stationary frame of reference. Now of course that implies that the wind is in a moving frame of reference. And we're told that the wind appears to come from the southwest. So that implies that if the wind is in the moving frame of reference, which means the man is in the stationary frame of reference. So just to distinguish the two situations, I've put 2's and 1's on these. The other thing to notice, of course, is that VWM1 and this is incorrect, VWM2, their magnitudes are not necessarily the same, because obviously depending on how the man is moving, he can perceive the new wind velocity to be different. So I'm just going to call them for the moment W1 is equal to W2. So we know, of course, that VWM1 is equal to VW minus VM1. That's going to be equal to, now we've an angle, so the cosine sine of 45 or 1 over root 2, so it's just going to be W1 over root 2I plus W1 over root 2J. And that's going to be equal to the velocity of the wind. I'm arbitrarily going to call it AI hat plus BJ hat. And we need to take away from that the velocity of the man. And initially he's moving due south at 1 meters per second, so that is negative j like so. And what we get as a result of that is that AI hat plus BJ hat, that's the velocity of the wind, is equal to, so it's going to be W1 over root 2 in the I hat direction, of course, and it's going to be, there's a negative here, that's positive, so it's going to be plus W1 over root 2 minus 1 J. Now let's just look and see if that's correct. We're taking away, it's going in the southerly direction, so that's minus, okay? And we need to take that away, so that that's a positive number, and when we bring it across, it once again becomes a negative number. Alright, so let's get rid of this piece of information here, and I'm going to call this scenario 1. And of course, the velocity of the wind will never change. So what we need to do now is use scenario 2 in order to get another expression for the wind vector. So drawing it in green again, we're going to get, it's this time positive I but negative j. So it's going to be positive root or W2 over root 2I minus W2 over root 2j. That's going to be equal to the velocity of the wind, which is going to be AI hat plus BJ hat. And we need to take away from that the velocity of the man. This time he's going 0 I hat plus 3j. Alright, because he's going in a northerly direction. So I'm going to write scenario 2 in black underneath scenario 1. Alright, so that turns out then that you're going to get AI hat plus BJ hat equal to, it's going to be equal to W2 over root 2I. Actually, just one sec there, the velocity of the wind. Let's just to be consistent with what we've written up above. So it's W2 over root 2I. And then we're going to get This is going to be a negative number, and when you bring it across, it's going to be a positive number, plus the following. It's going to be 3 minus W2 over root 2 J. Alright, now both of these are equal. They have to be equal because they're two different ways of writing the velocity vector. So if they weren't equal, then they wouldn't be the velocity vector of the wind, of course. Okay, so if we just compare the I hat components, we're of course going to get the W1 over root 2 is equal to W2 over root 2. Therefore W is equal to W. And from now on I'm going to say W1 is equal to W2 is equal to W. Alright, so that's some good piece of information we're after getting. Now we compare the J hat components, you're going to get the following. Alright, so let's just rearrange that. You're going to get 2W over root 2 is equal to 4. And that W is equal to 2 root 2 meters per second. That is correct. So W, the magnitude of W is equal to 2 VW will say, 2 root 2 meters per second. Now we just need to finish the question. Alright, so let's just go back up here and apply the knowledge we've just worked out to any of the scenarios there, 1 or 2. So we're going to get the velocity of the wind is equal to AI hat plus BJ hat is equal to. So this is going to be 2 root 2 over 2 over root 2, excuse me, I hat, plus it's going to be 2 root 2 over root 2 minus 1 J hat. Alright, I'll just get rid of these now just for clarity, we don't need those anymore. And we're going to get that VW is equal to AI hat plus BJ hat is equal to 2I hat plus J hat. And that's correct. Alright, so like I said, actually it wasn't that difficult. Once you thought about it and let your algebra be reasonably good, you were flying it. So thanks for watching. Please pass it on to your friends and subscribe to my channel.